The session state storage system maintains distributed, replicated session data across clustered nodes. Each session is assigned a unique identifier and associated metadata including creation timestamp, last access time, and serialized attribute map. The system provides eventual consistency guarantees with optional strong consistency modes for critical operations. Sessions expire according to configurable TTL values ranging from 300 seconds to 86,400 seconds, with default expiration set to 3,600 seconds. Session objects are serialized using the standard binary codec and stored in a key value format within the distributed store. The primary key structure follows the pattern session ID, with optional secondary indexes on user ID and creation timestamp. Attribute values support strings, integers, floats, booleans, and binary data. Large attribute payloads exceeding 64 kilobytes trigger automatic compression using deflate compression at compression level 6. Replication occurs synchronously to primary and secondary replicas designated by the cluster topology. Write acknowledgement requires confirmation from the primary node only, with secondary replication proceeding asynchronously. The replication lag is typically under 50 milliseconds in standard deployments. Replica membership is determined by the cluster configuration service and updated dynamically when nodes join or leave the cluster. The failover mechanism activates when a session's primary node becomes unreachable. Secondary replicas are promoted based on replica priority and network latency. Failover detection occurs within the configurable heartbeat timeout window, defaulting to 10 seconds. During failover, session writes are held in a local queue until the new primary is established. Sessions on failed nodes remain accessible through replica nodes with a maximum 5-minute window. Session state snapshots are persisted to durable storage at configurable intervals. The snapshot mechanism captures all active sessions and writes them sequentially to a snapshot file with a 32-bit CRC32 checksum appended. Snapshots are stored with timestamp-based naming convention. Session snapshot epoch seconds.bin. The system maintains rolling snapshots with configurable retention, defaulting to 7 days of historical snapshots. Recovery from snapshots occurs during node startup. The most recent valid snapshot is loaded, followed by playback of transaction logs recorded since the snapshot. Log playback applies session creation, attribute update, and deletion operations in sequential order. Invalid or corrupted log entries are skipped with warnings logged to the operations log. Recovery time scales linearly with the number of active sessions, typically 50 to 200 milliseconds per million sessions. Attribute access patterns are tracked using a least recently used metadata layer. Each session maintains an access timestamp updated on read and write operations. The access frequency histogram is bucketed into 60-second windows and used for adaptive prefetching on replicas. Sessions accessed less than once per hour are candidates for lazy load eviction policies, reducing memory consumption on secondary replicas without affecting availability. Concurrent access to session attributes is managed through reader-writer locks implemented at the attribute level. Multiple readers acquire shared locks simultaneously without blocking. Attribute writes acquire exclusive locks, blocking all readers and writers during the update. Lock acquisition timeout defaults to 100 milliseconds, after which operations fail with a timeout exception. Deadlock detection runs periodically on a 30-second interval. The consistency model supports 3 modes: eventual, read-write, and strong. Eventual consistency allows immediate returns without waiting for replica confirmation. Read-write consistency guarantees that subsequent reads on any node reflect previously written values. Strong consistency waits for acknowledgement from all configured replicas before returning. Mode selection is configurable per session with strong consistency incurring approximately 15 to 25 milliseconds additional latency. Session invalidation can be initiated explicitly or automatically by TTL expiration. Explicit invalidation removes all attributes and marks the session for deletion. The deletion is asynchronously propagated to all replicas with a configurable grace period of 60 seconds to allow ongoing requests to complete. Invalidated sessions cannot accept new attribute writes, though reads may return cached values on replicas until the grace period expires. Monitoring and metrics collection is performed by the metrics client library. Key metrics include session creation rate, session deletion rate, average session size in bytes, and attribute access latency percentiles. Metrics are bucketed into 60-second intervals and aggregated across the cluster. The metrics export interface supports push and pull models with configurable flush intervals defaulting to 30 seconds. The session mutation log records all write operations for audit and recovery purposes. Each log entry contains the session identifier, attribute key, previous value, new value, operation timestamp, and source node identifier. Log entries are stored sequentially in append-only files with automatic rotation at 256 megabyte boundaries. Log retention follows the configurable rolling window, with default retention set to 30 days. Batch operations allow atomic updates to multiple session attributes within a single distributed transaction. Batch write operations acquire locks on all affected attributes simultaneously to prevent interleaving conflicts. Batch operations provide all or nothing semantics. Either all attributes update successfully or no changes are applied. Batch size is limited to 1,000 attributes to prevent excessive lock contention and memory allocation. The session store supports conditional writes using comparison predicates on current attribute values. Conditional operations are specified using simple comparison operators: equals, not equals, less than, greater than, and contains. The predicate is evaluated atomically with a write operation to ensure consistency. Conditional write failures are returned as non-exceptional status codes rather than exceptions, allowing efficient polling patterns. Client libraries are provided for standard languages including Java, Python, Go, and C++. The libraries implement connection pooling with configurable pool size defaults of 10 connections per node. Reconnection logic uses exponential backoff with a base delay of 100 milliseconds and maximum delay of 30 seconds. Connection timeouts default to 5 seconds for connection establishment and 30 seconds for operation completion. Configuration is managed through a YAML-based configuration file with environment variable overrides. Common configuration parameters include replication factor, session TTL seconds, snapshot interval seconds, consistency mode, and log retention days. Default configurations are suitable for most deployments. All configuration changes require node restart to take effect, with the exception of consistency mode and log retention days, which support dynamic updates.